Bismillah ar-Rahman ar-Rahim. My name is Hanan Sa'adeh from Jordan. I'm Assistant Professor of Atomic and Molecular Physics at the University of Jordan, Department of Physics. I'm also, since few years, like more than 5 years, work as a research fellow at Elettra Synchrotron Trieste. And first of all, thanks to the SESAME organizers and specifically to the ESUO that invited me to deliver this talk showing my humble experience of using synchrotron radiation in European light source such as Elettra. Actually, this is my first time to be invited speaker in my home country. So normally in my home country I host invited speakers. But this time, thanks to, again, ESUO and to my friend Ozgul, I'm sure she endorsed my name, for giving me this opportunity. Normally, when I present my work abroad, I used to show a map smaller than this one, focusing on Asia, and specifically focusing on the region where I came from, Jordan and Palestine. But since about 5-6 years, when I joined Elettra as a Synchrotron user, I started to show this big map showing that I'm oscillating between two accelerators, one at the University of Jordan, which is ion accelerator, ion source, and the other one is the light source at Elettra. So since about a few years, I have keeping two eyes, one at my beloved university, where is the accelerator where I grew up and I started my career, and another eye at this paradise in Elettra in Trieste in Italy. When I was invited to give this talk, the invitation letter proposed that I have to highlight two things. The first thing is my current research at the European light source I used as hopefully a potential user in the region for SESAME. And the other part of the talk will be to highlight what kind of opportunities I got to access such a European light source for a researcher from this region, from developing country like Jordan. So to give the talk in two parts, I would highlight that all my work in synchrotron was based in Elettra. I had the chance to be honored to pass by or to visit or to spend few hours or few days at two more synchrotron sources, but I didn't find the setup that I need, the field that I could join, the people that I could collaborate with, except at Elettra. So all of my work will be of Italian fingerprint, let's say. And the other part of the source of the talk will be about the opportunities I get, and I would like to highlight none of these experiments, none of these travels, none of these proposals or mean times were done in any way related to any financial support from SESAME. Now, what kind of physics I'm doing? I'm doing atomic and molecular physics. I'm used to do atomic and molecular physics using ion atom collision. When I joined Elettra, I started to use photon beam in place of ion beam. And in a simple way, I can say that what I'm doing is soft X-ray and vacuum ultraviolet spectroscopy in the energy range not greater than 1 kilo electron volt, and starting from a few electron volt in order to study basically the valence and core electronic structure of atomic systems and molecular systems, and mainly in gas phase. And to make it simpler, I could say that we use the light of the synchrotron to shine on materials in form of isolated molecules, regardless of the environment, away from the biological environment, the atmospheric environment, whatever sample you have. If I'm interested in, I should bring this sample first of all to gas phase. Once it's in gas phase, it's my sample. Otherwise, I cannot touch it. I don't work on solid, I don't work on liquid. So I tested some samples like originally behave as liquid in room temperature or solid, but I brought them first to the gas phase, then I did my experiment. Doing the experiment, I normally use or employ the methods that are typically used by other branches of science, by life sciences, by surface sciences, but like X-ray, photoelectron spectroscopy, like positive photoelectron, photoion coincidence spectroscopy, all these kinds of typical measurements I could use, provided that the sample in gas phase. If we do such measurements using synchrotron radiation in gas phase, what we learn is a very basic concept about the structure of the molecules, and if we do coincidence, we could learn about the fragmentation patterns of the molecular ions. This is a very basic information, but we believe that this would open horizons and a new perspective about more complex molecules and more complex systems. Examples for these molecules could be from atmospheric chemistry, could be from biological molecules, could be from molecules that are used in pharmacy, like drugs, like medicine, could be anything. But we can provide the very basic idea, which is the atomic and molecular structure. Now, the experimental setup that I used in gas phase mainly was by using this end station. There are many end stations at gas phase, but during the years, I focused on using this end station. Any sample can be brought in gas phase is a suitable sample for investigation. The main parts of the setup is the electron analyzer in order to resolve the detected electrons after the photo-induced fragmentation, to analyze them by electron analyzer. Also a time-of-flight spectrometer in order to detect the photo-induced fragmentation or the molecular ions produced after the photon-matter interaction. And the other are the cooling system, heating system for evaporation, pumping system. So this is an actual view of the end station I used at gas phase, beamline, and Electra. Examples for some case studies that I took part in during the years. I would start with this first example, which was basically the first experiment I joined in Electra. You will not find my name in the list of authors, because when I joined, I went to this experiment just to learn. A few years after that, I realized that I was mentioned in the acknowledgement, even though in 2015 I didn't know. So for me it was very exciting that they recognized that I did effort, because I remember I took part in the experiment and even in data analysis, but it was almost the end of the experiment. But I learned a lot from this experiment. The idea of this experiment is very simple. There are many chemical structures or chemical compounds that exist in the atmosphere. I tried to reflect the applications of atomic and molecular, even though our main goal is to study the basics. But let's say to highlight that we are useful to other communities in the scientific field. So one of these molecules that exist in the atmosphere is CH2I2, which is diiodomethane. And this is one of the diiodo or the dihalomethane that exist in the atmosphere. These compounds, when they interact with the vacuum ultraviolet or with the normal ultraviolet in the atmosphere, they fragment. And these fragmentations, they behave differently according to the situation of the experiment, let's say the wavelength and the temperature, the pressure, the environment. What we can provide as atomic and molecular physicists, we can study this molecule in isolated space. By the way, this molecule is liquid, but we brought it into gas phase, and then we lit it into ultra-high vacuum chamber to study the electronic structure, plus to employ the photoelectron, photoion coincidence PEBICO technique that was shown in the experimental setup. What we learned what are the fragmentation patterns that are used by the vacuum ultraviolet photon-matter interaction. This kind of information would be very helpful for atmospheric chemists. This is an example for what we studied. Another example, a paper that nowadays I'm preparing. I did this work last year when I was in Electra. Actually, this was last August. It's about studying the ion fragmentation and the electronic structure of a family of molecules. They are called indoles. Indoles are kind of molecules that exist in the natural organism, in the humans and in other kind of living living items. These kind of compounds, the indoles, they exist in the pigment of our body and also of animals and other kinds. So these kinds, they exist in the pigment, and this pigment is used or supposed to protect our body from the sunlight. So the proposal was to study what is the electronic structure and the fragmentation pattern, especially that we also got some help from theoreticians who are interested in the electronic structure using the density functional theory. And we did the experiment last August, and we found, let's say, a good correlation between the results that we obtained and the results that were obtained earlier by our theorist collaborators. And this example is also, the application is very close to life, but our basic interest is just to know what's the fragmentation patterns. And another interesting example, which is closer to my heart, is this one, which is of pharmacological applications, that we noticed that the famous compound, which is already liquid, but we studied it in gas phase, nicotine, the mostly consumed compound in this universe, unfortunately, has a similar, quite similar structure to vitamin B, which is very useful to us. So what are the similarities and the differences between these two compounds? The best way to know the similarities is to go down to the atomic structure, to go to the single molecule state. This is the goal of atomic and molecular physics. So this is what we did. We studied the electronic structure using X-ray photoelectron spectroscopy, and we did also some mix-ups. And recently we got some calculations, and this paper is already submitted. It's basic electronic structure, but my hope that it will be accepted because it highlights a set of widely consumed molecules, vitamins, and on the other extreme, nicotine. These are examples. I introduced only the latest three. I did not talk about the already published ones. Now, the question that you might think about, are these related to SESAME? Will they be possible in the near future? The answer can be no, and probably yes. No, not so far, for sure, because now we don't have except IR and hard X-ray. I know this very well. But let's say, optimistically, this would happen in the future. We learned about HISP, thank you so much. We learned about HISP yesterday, and this gave me a hope. Already I had it since, let's say, last January, because I'm following very closely the story of HISP. And I am so excited until this comes to ground, not only to the level of documents and memorandum of understanding and agreement and contracts. I'm longing to the moment that I will see it on the ground, and I trust after all these challenging trip of SESAME, this fourth beamline should come to light, let's say. So this is a hope. And looking at HISP, at the HISP beamline, at the website of HISP beamline, and reading the story where it started, yes, it's a soft X-ray beamline, but unfortunately, all applications that are highlighted on the website, and already highlighted by you yesterday, they all related to cultural heritage, to surface sciences, and so on. Nobody mentioned any single word about basic research. I would like with this talk to raise this point, that, please, no? Okay, shall I shout?
Yes.
I have been shouting since 8 till 2 p.m. today. Okay, do you hear me?
Yes.
Okay. If I forgot that it's a conference presentation, then I started to give a lecture. So, going back to the website of HISP, unfortunately, nobody mentioned any single word about basic research. I know that my field, atomic and molecular, is a very basic research. Nowadays, all the fund in scientific societies, even if you submit a proposal, I showed the examples that I submitted in Electra, those examples that I highlighted, the biological interest, the pharmacological interest, the atmospheric chemistry, because I know the panel, they look, okay, this can be done. The experiment is possible, but what's the benefit to the scientific community? What's the benefit for the R&D in the country? Because, you know, in the accelerator, they pay you the travel, they pay you the beam time cost, you pay nothing. So in order to host you, they need to host some application, something well justified to the community. So unfortunately, I have hope for HISP. But so far, I didn't see any window for the atomic and molecular. But let's say, to be optimistic, I'm following the plan. They started in January 2019, and probably the beamline will be ready in December 2022, or probably in the summer before there will be the first friendly users. I trust that if it comes to light, what I can do from now till that moment, I can only do good science. And I will keep doing that at Elytra, and probably if I get a chance somewhere else, I will keep doing good science until this beamline comes to light. And I already learned that there is a group, Turkish group, if I remember well, they are planning to provide the first end station. Probably, if this was successful, I could convince my collaborators in Italy, let's also submit a proposal for atomic and molecular. Who knows? Maybe it comes like through one of the dreams. 6 years ago, I was not dreaming to be part of Elytra. Now I am. So let's hope. And back to the presentation. Based on that, I still have wish list that I already mentioned. A soft X-ray beamline, it was my wish list since many years ago to be in SESAME. Thanks to Germany, this will happen. It's already almost there. The second wish is to have a gas phase end station. I think I should keep doing good science. We will reach there. No one knows. Maybe in 2029, who knows? And the third point, I always raise this point in the SESAME meeting. I hope that one day SESAME could accommodate in educational beamlines. Because you know, I'm coming from a university. I have two hats, a researcher and an educator. So I trust that if you are a researcher and a teacher at the same time, you should be somehow creative. It's much easier to bring the students to a beamline in order to convince them, let's do experimental work. Nowadays, the majority of our students are rushing into computational. Not theoretical, also computational. They want a free code, and they just want to put input, with my whole respect to all fields. So I do believe that we need those experimentalists in basic science. Let's have educational beamline. Let's put this on the wish list. Now, this is the first part of my presentation. What's my current work at synchrotron radiation? I tried to make it brief because I know the majority are not atomic and molecular physicists, and I would save some time for the second part of the presentation, which is the story of how I got involved with synchrotron radiation. I will try to make this long story not short. I will try to make it interesting. This is my timeline. I started my PhD work at the University of Jordan Van de Graaff Accelerator in 2005. It was my first experiment in life because I started my PhD directly from bachelor. I didn't have master, so my PhD research was my first research. Shortly after that, you can see the peaks in my life. There was a peak in 2009, I will come to it. Then in 2013, I got my job at the university as a faculty member. In 2014, there was another peak in my life, and the biggest peak was in 2015 and again in 2018. Let's start. I started in 2005 as a PhD candidate in the University of Jordan using our electrostatic particle accelerator. JOVAC is the University of Jordan Van de Graaff Accelerator. It's an ion source, and this is an actual view of JOVAC. And briefly, it's again a gift from Germany. So I always excited when I hear that there is a support for an accelerator from Germany. So my accelerator was from Germany, and it was born in 1980s. I was born in 1980. So I and my accelerator almost the same age. It's an ion accelerator. We basically have 3 operational beamlines. It's very special for me. I will not tell you the story about it, but I can briefly say it's the first accelerator in Jordan, the only ion beam analysis facility in Jordan, and above all, it's the place where I was born as a scientist. I got my PhD there. So one of my ultimate goals in my life is to keep this accelerator always running, to keep its light, we call the beam there also light, to keep its light always existing. And then the peak came to my life. I started in 2005. I designed an experiment in ion-atom collision, which was the first of its kind in the region. It was very challenging, thanks to the smart idea of my ex-advisor at that time. In 2009, the peak that I found an opportunity to go to attend a school at ICTP very much related to my thesis. I was looking to some literature to compare. I didn't find literature to compare with my experiment because it was the first of its kind. But I found a school in ICTB. So I rushed to my advisor at that time, and I told him I would like to apply. The good thing that he wrote me a very strong recommendation letter. He said, I deserved it. I hope so. The bad thing that he said, what if you got accepted? I said, I will go. I will go to Italy. He said, but who will look after your accelerator? And I convinced him, look, it's only 6 days. My accelerator will not die. I will come back with a new knowledge, with a new experience. Anyway, he let me to go, and I went, and a new chapter in my life started. Oh my God, ICTB. When I applied, I never knew that ICTB is of this great mission until I arrived there, and all my life changed. Then I went back to Jordan. I defended my thesis end of 2009, beginning of 2010. And I kept working at the University of Jordan Bandigraph Accelerator, no salary, nothing is paid, nothing, until I got a job outside Jordan. Then I came back as a faculty member in 2013. The point is that since 2009 to 2013, probably I attended 7 to 8 activities paid by ICTB. Imagine, more than twice a year I was in ICTB. So I became ICTB girl. In 2013, I got the position as a faculty member, and I learned a lesson. I should keep my students attached to this facility to keep the life going on. But also, I should scatter them abroad. I should send them to see what I never saw when I was a student. So I spread my students in CERN, in ICTB, in Pakistan, in Germany, wherever I have a chance. And of course, they come back with a great experience. The peak happened again in 2014. I was in a conference in the National Center of Physics in Pakistan, Islamabad. To those who know NCB, it's a replica of ICTB. And there I gave a talk about my work in the accelerator. And let's say I highlighted here two guys, two gentle scientists, let's say, and there's a third one, the gentleman in the corner. Probably, for sure you know him, Dr. Aslam. And he asked me a question. He said, you gave a very nice presentation. By the way, the meeting was International Scientific Spring. It's related to any part of science, not only accelerators. And probably I was the only one who was talking about accelerator, ion atom collision. There was another one who talked about synchrotron, this nice man, Paul Bishi. And Mr. Aslam Beg asked me, will you work at SESAME when it becomes operational? This was 2014. I said, probably no at the beginning. I joined SESAME meetings since 2002, when I was a student. And I'm following what is the beamline 0, what is the first day, what is the second beamline. So I know the story, it's going to higher and higher wavelength, let's say. So then at that time I said, probably no, because it's not my field. I'm an atomic and molecular physicist. It seems that my answer was not diplomatic. Then I learned the lesson. But two guys, two gentlemen at that time, they spoke to me independently. One of them, the one on the left, is Dr. Joe Nemella, who was at that time the director of the external activities at ICTB. And this was the second presentation that Nemella attended for me. And he said, look, I really feel sorry with these enthusiastic presentation and these achievements of you, and you are still in Jordan. You should have chance to go abroad. Look for any accelerator and try to make a collaboration. I thought, yeah, but I did my PhD in Jordan. Nobody knows me. I'm nothing abroad. He said, but ICTB knows you. You should apply to ICTB. I'm the director of the external activities. You should apply. And from that moment, I decided to apply. And independently, George Balushi, at that time, was in a transition state, and I didn't know. He was coming as a lecturer, but Dr. Hafiz Qurani, also in the corner, was still the active ICTB, the active SESAME scientific director. And Balushi came and talked to me because, you know, he's going to Jordan, so he's looking for any Jordanian. I was the only Jordanian. And he talked to me, are you interested to work in soft X-ray? I'm also, he said, I'm used to be an experimentalist. I said, okay, fantastic, I'm experimentalist. He said, I'm an X-ray man, a soft X-ray man. I said, but in which field? And he said, surface science and so, the field that I'm not interested in. I said, okay, but I'm atomic and molecular physicist. He said, okay, no problem. I have friends who are atomic and molecular physicists. When I go back, I will write you an email. I thought he will remember anything except that lady that we met, and he said, I will write to one of my friends. Less than 2 days, I received an email, not from Georgia, but from other friends in Electra. They are contacting me, approaching me to look at their publications and to visit them and to make collaboration and to send them ideas. Okay, and Babushi is in CC. I was so excited. And at that moment, I started to submit my application to ICTB, and I mentioned the lab. I wanted to go to gas phase beamline Electra. I was so profound and so confident that I know where I'm going, because he introduced me to the people who are well known in that field. And I got accepted, and I went back to my university very, very happy. I met my ex-advisor, who became my colleague, and he said, oh, that's good, but really you will leave for how long? I said, 3 months. He said, oh, 3 months, too much. Who looks after the accelerator? Oh my God, I will do. The 3 months will be in summer. I will look after the accelerator in the first semester, the second semester. Anyway, I went to Electra, and I found myself there. And I made another home. I have a home in Amman, and I have a home in Electra. By home, I mean the lab. Back to the timeline, then from 2015, I kept going to Electra. Every summer is Italian for me. You don't find me in Jordan. From June, sometimes from May. If they release me at the university, I leave at May. From June to September, I'm Italian. And the peak happened again in 2000, end of 17, beginning of 18. When I was awarded a 1-year fellowship from ICTB, funded 50 by ICTB, 50 by Electra. This was a very exciting moment in my life. Another new chapter started. This photo in the accelerator in Jordan, Juvat, not because the experiment was very well, no, the experiment was not running. But at that moment, Kersi visited me. And you know Kersi, she makes joy and fun and makes the atmosphere fantastic. And at that time, a few days before Kersi came, I got the news from ICTB and Electra, I'm invited. I'm just in a stage to convince my university. So this is the reason of this big smile that I'm not used to. And then I submitted my application to the university for a 1-year leave. Luckily, they approved because this is the first 1-year leave in my life. But everybody asked, and not only my ex-advisor, not only my colleagues, even my mother. She said, who looks after the accelerator? Oh my God. And nobody remembered that I'm the only scientist working in this accelerator. And for me, it's more than my home. It's my first home. And if you look at the history, you will find the last PhD done in this lab was mine at the end of 2009. By the way, in this month, I'm celebrating 10th year of PhD work. So it was mine. The last PhD defended in this accelerator was mine. And you ask me, who looks after the accelerator? And also, the most recent master thesis will be defended in 2 weeks from now. It's also mine. It's for my student. But when you got a chance, everybody asked, who will replace you at home? And again, I did it. And I was in Electra, but this time as a 1-year resident. And I don't want to say how much it was fruitful, how much it was a fantastic year. I think you all can imagine because probably you had better experience than mine, but this is how I got the chance to be a synchrotron user. I started as an accelerator user, and I'm still an ion beam accelerator user, but also now I have another identity. You know the photon behave as a particle, travel as a wave, but interact as a particle. I have 2 identities, Italian, let's say, synchrotron, and Jordanian ion accelerator. What I gained from SESAME, I joined all workshops that were organized by SESAME and mostly all meetings. I only missed 1 meeting in SESAME when I was a PhD student and they did it in Cairo and I was not funded to travel there. This is the only meeting I missed in the users meeting. So I joined the user meeting before becoming a user from the 0 meeting, let's say. Not the 0, but relative to me, it was for me the 0 meeting in 2002 when I was a student. I joined most of the trainings of ICTB, of SESAME, not only those related to my field, but I'm also willing to learn. So usually I learn. If you look to my CV, you will find that I attended about 80 to 90% of SESAME schools. And if you don't find me in the pictures, look carefully. You will find at least 2 of my students. If I don't go, I endorse my students. This was the last one last November, the Hercules School in SESAME. Also, what I got in 2013 from SESAME, there was a school link scheme project. Probably most of you remember that project. Actually, it's far from my interest. It's computational and high computing and so on. I give it a try. Let's see, because this is SESAME. I should get benefit from SESAME, so I joined. The exciting thing that there was an award or a grant for the best performing students, best performing participants, and I was selected as one of the 2 best participants, and they sent us to ESRF to visit and communicate with people. And it was a very nice trip for me because this was the first synchrotron light source I visited. This was in 2013, but unfortunately, I didn't find place for me because of the energy range, and I didn't find the beamline that I could join. But I learned a lot from the experience of the people, and I made friends also. Another thing I gained from SESAME, that I was selected or nominated as a SESAME Users Committee, SESAME. And many of my colleagues, they ask me, why you? Yes, I'm not known. Not well known in Jordan, why me? Myself, I was surprised also. But when I checked, I was selected by the person who was elected or nominated before me, and he selected me based on my work at Electra. So again, thanks to ICTP, thanks to Electra, I was selected to SESAME because of my work at the synchrotron radiation. At the beginning, I refused the offer. But then when they convinced me that this is a free job, let's say, this is a role that you have to do for SESAME, and I care about SESAME, and I care about the community. And then I accepted when I knew that, okay, you were endorsed because of your colleagues at Electra. Somebody of them endorsed you to Jordan, and then Jordan selected you or nominated you. And another exciting moment, the opening of SESAME. It was the last thing that I could imagine that I would be invited. The exciting thing, I got the invitation like 2 weeks before the opening of SESAME in May 2017, and it was, as you can probably see, it was signed by the president of SESAME Council, a person whom I never met in my life. The most exciting thing that when I went there, number of Jordanians who attended this meeting was minimal. But let's say, I'm comparing to my university. From my university, only 2 figures attended. The first one is the president, because he's the president of the oldest university in Jordan. He should be invited. The second one was myself. I was so excited when I met him. I didn't know that he's attending. I expect yes, but I didn't know. And he, of course, does not expect that I'm there. And he asked me, I remember your face. In which faculty? Pharmacy? No. Agriculture? No. I said, I'm physicist. Thanks God, he knows my name, but he never met me. And he asked me, so why are you here? Who invited you? I said, SESAME Council's presidents, plus I got also invitation from the princess. And so funny that I was invited to the dinner and the president was not. He told me, really? I'm not invited to dinner. And then I had the chance, for the first time, to get the photo of the Princess Sumaya. Actually, my mother was happier than me, you know? And those who sent me the photo are my colleagues from ICTV, because they were attending, thanks to Dr. John Emella. He was there again, and he said, I'm here just to take you photo with the princess. And you can ask me, what did you contribute to SESAME? I can say, I really contribute to science. I think this is my role in life as a scientist. If I have a chance to join a meeting, to join a committee like SESAME, I will never save time to say, no, I cannot. I will do it for the sake of SESAME because I'm dedicated for science. So I do believe that what I contributed to science, I do contribute to SESAME and, of course, to my country, Jordan. And one of the very minimal things that I normally don't talk about, but after a few years in Electra, I have submitted like an informal proposal to have a future atomic and molecular beamline at SESAME. I don't think that it was recognized by the SESAME Council, but who knows? Maybe in the next few years I become more famous, my science, my publications becomes more cited. Maybe someone would remember there was a proposal, you don't know, but I did a try. Also, what I keep going every day, on a daily basis, I teach physics. I teach physicists and engineers. And I always endorse my students to come to SESAME, and I also bring them with me. And this photo was in 2018. One day before I leave to Electra for 1 year, I brought my students, physicists and engineers, bachelor and master, to SESAME. And thanks to the staff in SESAME, they spent like 4 hours with us, between lecturing, tours in the Coltron room, in the beam lines, the experimental hall, everything. I was surprised, like 2 weeks ago, I received a message from the organizers of the International Day of Light 2020, which will happen next May, inshallah. They posted the photo of my students while visiting the light source in the Middle East, while visiting SESAME. They posted this photo on the newsletter of November. This was another exciting moment. So thanks to SESAME, because of SESAME, my students became famous. And probably this is all. So thank you for attention. I hope I did not overcome the time allowed. I should not forget to thank all those people who supported me in a way or another, but let's highlight, first of all, my university. Because of the degree that I got from this university, a well-respected degree, I will never be appreciated, neither in ICTB nor in any place. So thanks to the solid background, although I'm atomic and molecular physicist, but I do believe that I built a solid background of physics in my university, even though they did not fund me financially. Thanks to the financial and generous support, first of all to ICTB, and then to Electra during these 5 years. And also there was some money came from another accelerator, Ion Accelerator, LABEC and IAEA. For SESAME, even those workshops, those meetings, they also added a lot for me, and it's enough. When you go abroad and they ask you, where are you coming from? And you say, Jordan. Oh, the country of SESAME. Do you know SESAME? And when I stand up and say, yes, I'm a member of the SESAME committee. Oh, really? This is, for me, is a moral support and more than enough. No words can say how much I'm grateful to my family in Electra, my colleagues, my friends, and if you allow me to give you a take-home message, there is no better place to enjoy experimental physics than accelerator laboratory. If you have an accelerator, look after your accelerator. And also, 2 accelerators would be better than 1. It's nice to work on an accelerator at your home country, but also why not to jump to Italy every now and then, or probably to Germany, who knows? And if you allow me to conclude, I have only one conclusion. Who looks after the accelerator? The answer should be the one who's looking ahead. Look ahead and look after your science. Then you will be an added value to your accelerator. Thank you for listening. And this is from Trieste, because in 2 weeks I have Mintam there. My colleagues sent me this message in the end of November. Trieste is already decorated for Christmas. And that's it.
Yes. Thank you very much for your very nice talk.
I'm tired.
But very good. And
thank you.
If I can say something with respect to Essen, really feel welcome to share your needs and your.
I will do.
And because this is, I think, a beamline that would be. If you would like to use it,
of course.
I'm
waiting, impatiently waiting.
Yes. So feel free to say what you want.
Thank you so much. Thank you.
Yeah. So any question or comments for you?
Hanan?
For Hanan? Tell me.
Yes, maybe.
Okay.
How many? It's always the same. When you have a nice proposal, as you proposed, of course it's exciting, and people, management look at your proposal. But it comes to a committee, and the committee always asks, how large is your community? How many people in Jordan, in Europe, in the member state, are working on the emission of gases?
Okay. As far as I know, I believe that this community of atomic and molecular physicists,
exactly.
Accelerator-based atomic and molecular physicists, are few. But I do believe also that it will be an added value to get such a beamline in in SESAME. Sorry, I mix. Why? Because if you look at the synchrotron-like sources in Europe, not every synchrotron-like source has atomic and molecular beamline, right? And the calendar of gas phase, because I have been in gas phase for years, and last year I was there on a daily basis, you know, so I know how they manage the calendars, how many proposals they get, how many they accept, and how many they put on the waiting list. So there is a demand on the few gas phase beamlines over all the world. So if there would be one in the Middle East, it will open the door not only to build this community in these countries, but also to host the experts from all over the world. Because those who are submitting proposals for gas phase at Electra, sometimes they don't get the chance. Not because their work is not exciting, no, because there is no room to host all these experiments. I mean, there is no space in the calendar. So they go to other accelerators. For example, they go, Soleil, for example. But if you count, there are many accelerators, synchrotron light sources, that they don't have this sophisticated end station. But why not to open it for SESAME? Why not to host this? And also, start the facility, then you build the community. I'm looking for the moment that I can supervise the students in this field. I couldn't, up to now, since 5 years, I never succeeded to take my students with me to Electra. The problem is the lack of fund. Sometimes I get full fund from ICTB, but also ICTB budget is limited. Sometimes I got half fund. So for me, to get a student to start from scratch there, it's time consuming, money consuming. So I supervise my students in Jordan, also using a sick facility, let's say, but we are digging the ground and we are doing some hope. But on the other side, I'm doing parallel on the photo emission and so on. I'm waiting for the moment that I could do this in Jordan. So then I can jump from Amman to Allan. Oh, life would be very easy. And there is a guest house here, and you know for sure that atomic photo emission takes time. There is no experiment that I had run for 1 hour or 2 or 1 night. Sometimes there are experiments for 3 times beam on target. 3 times beam on target. So having a guest house here would be a nice idea. So this is the point. So yes, we are a small community, but we do exist. And I do believe that we also provide science with new horizons. I met some users who are biologists, who are chemists, and they are interested to know the basic structure. And this is very basic. And I remember a few days ago, there was a new director hired for ICTB. And I listened to the talk on the web, and he said a word that really touched my heart. He said it would be, let's say not literally, but I would transfer the meaning. He said, we would be very stupid if we underestimate the basic research. We should start with the basic research. And he said this is one of the main missions of the ICTB. And yes, because of that, they funded me. Basic research is really important. It has the meaning of its name. It's basic. You cannot understand DNA if I didn't tell you about the amino acids. And this is what the people at GASP is doing. They are studying amino acids and stuff like that. And this is my point. I don't know. But thank you for raising the point. I hope it was not boring.
No, at all. Not at all.
Thank you so much.
Any other comments, question? No?
If not, let's go to
thank you very much.